Welcome back to Everything Mathematics, and today we are going to finish our part 3 of 3 videos in the way in which you calculate the area of a triangle. We would have started this last week Friday. As I said yesterday, we had part 1 looking at half base times height. Yesterday we looked at Heron's formula, and today we're going to be looking at this one here, half AB sine C. So what's our objective for today? For today, we're going to understand the conditions for when half AB sine C can work to calculate the area of a triangle. And of course, we're going to practice a few. We're going to calculate a few areas or the areas of a few triangles using this formula. So when can we use half AB sine C? That is very simple, and that's the first thing you need to learn, so that whenever you're asked to calculate the area of a triangle, all you need to do is look at your conditions in front of you. To calculate the area of this triangle, what you need to be given is two sides and the angle and an included angle. What am I saying? You need two sides of the triangle and an included angle are given or can be found. Note, the included angle used must be the angle between the sides being used. So for example, just a quick illustration. If I have this triangle like this, and if I am given side A and side B, then the angle that I'm looking at must be sine C. Good? If I have a second scenario, supposing that sine A and sine B here is given, then the angle between these two sides would be my C. That's the angle that I want. And of course, it's a triangle, so there are three possibilities. Is if here is A and here was B, then I think by now you get the pattern. The angle that I am using is this one here. Ha, kidding, just joking, just watching to see if you're paying attention. Yes, it's this angle here. It must be the angle between the two given sides. And I will throw it out one time because next week we will be definitely hopefully touching circles, and this formula comes in very handy when calculating the area of a segment, because to calculate the area of a segment, you literally have to calculate the area of a triangle, and then you have to subtract that from the area of a sector. So to put it into perspective, when you get a circle, and of course this is your radii, so you have one radius, two radii, so this here will form a sector. And oftentimes from a sector you could get a segment. This shaded region here below, it's a segment. And then a lot of students struggle to find this area because they don't know how to apply half AB sine C. Because remember, you will be given this side, you will be given this side, and you will have this angle. So this will help you to find the area of this triangle, and that's the number one formula that we use when calculating areas of segment, and sometimes it helps with the sector too if you have it the other way around. Sometimes they give you the area of the segment already, and they ask you to calculate the sector, and the only information you have is that of the triangle. Oh, but maybe you're going a little too advanced there, but yes, you have to be able to do it. You have to be able to do it. So let's move on. That was just additional information that should come out sometime next week. So here we have a perfect example. We have a triangle and we're given two sides and an angle between. Oh, by the way, to calculate sine is a trigonometric ratio. I don't want to talk too much about it because we're going to be doing trigonometry a little later. But for now, all I could tell you is that you would need a scientific calculator to calculate sine, unless, like me, you memorized a few of the trig ratios, or you have advanced understanding on trigonometry so that you could actually make a unit circle and be able to identify the various trigonometric ratios. And all that I think is tertiary level maths. So more than likely at high school you'll be totally ignorant of these things. So for now, just depend on a scientific calculator, and that's okay. Even for CSEC, they expect you to use a scientific calculators for this. So let's go straight into it. How do I find the area? So again, like I did in the video yesterday, you could label A and B if you want. It's not a must, but the area of the triangle is equal to half AB sine C. And everything here is actually being multiplied, right? So we just substitute our values. So we have half. A I have as 4, so half times, I'm going to write A again, times 4 times 5, that's 5 look like a S, times 5 times sine of 30 degrees. Yes, that's just how we have to commit it to memory right now. And that's equal to half of 4, that is 2, and 2 times 5, that is 10. So that is 10. And I so happen to know sine 30. Sine 30 is 0.5. So our area here is actually 5 centimeters squared. Yes? But again, you don't have to get sine 30. As I said, you need your calculator. So if you have a scientific calculator, just press sine, then press 30 for 30, and then you press equal, and you should get a half. You should get a half. Or again, based on the scientific calculator that you have, sometimes you might have to put the 30 first and then press sine. Once you do that, you're supposed to get your 0.5. I'm doing it here again just to confirm. And yes, that's it, right? As to why 0.5, again, I don't want to go into that. I honestly, at secondary level, you don't have to know either. I mean, if you want to, it's good. To me, understanding it is always the easier thing to do. But I wouldn't go into that unless you really request it. Maybe I could make a video just for you to at least understand how to find the basic ones. But for now, the easiest way is honestly committing it to memory. Good. And here I have a very interesting scenario, and I did this on purpose. So we have to calculate the area of this triangle here. But notice that we are given our A and we are given our B. So we know if we have A and B, the angle that we need is supposed to be this angle here. But they didn't give us, or we don't have it. And thus, I'm going back to what I said earlier. If the angle is given or can be found, we could use this formula. And in this case, the angle could be found. We just have to apply an old technique that we know. And that is knowing what is the sum of the interior angles in a right angle, in a triangle. So the total sum of the angles inside of a triangle is supposed to add up to 180 degrees. That is something that we're supposed to know. So 180 degrees is supposed to be equal to 70. Okay, let me do this the other way around because I'm pretty sure most persons are accustomed to the other way around. So let's look at it this way. We are given 70 degrees plus we are given 40 degrees plus whatever the missing degree is, I'll put a question mark, which we don't know, that when you add those three, you're supposed to get 180 degrees. So let me put back my question mark here. Our question mark is what we don't know, but we know that if we add whatever the question mark is to 40 and 70, we're supposed to get 180. So from here is basically making the question mark the subject of the formula. And once we understand that, then we could get our missing angle and then go our happy way and calculate the area. So let's do this math here quickly. So 70 plus 40, that should give me 110. So 110 degrees plus the question mark is equal to 180 degrees. And to make the question mark the subject of the formula, all we have to do is transpose the 110 on the other side. Remember, it is positive here. So when it goes on the other side, it will become negative. So that will be question mark is equal to 180 degrees minus 110 degrees. So that question mark is actually equal to 70 degrees. Very good. So we have an isosceles triangle in the house. So this is 70 degrees. And again, if we apply the properties of a triangle, if here is 70 and here is 70, that means that this side and this side are equal. So if here is 10, that means over here is also 10 meters. And that's just an added fact. We didn't want it in this case, but I guess it will come in handy because in a case like this, then guess what? We could also use Heron's formula. Yes, we could. Right? So let's go with that. So now that we know that this included angle here is 70, we could do our maths. So let's find the area now. So the area of this triangle here would be half AB times C. And that's the same as half times A. I label A as 9 I label B as 10, and then sine, so times, we put a times the 2, sine times sine 70 degrees. And that is basically how we state our problem. And from here, we just compute. So half of what? Half of 5. Half of 10 is 5. I'm looking at the easier number. So half of 10 is 5. 5 times 9 is 45. So here we should have 45 times the sine of 70 is 0.9396. So I will stick to 4 decimal place, so that will be 9397. And I did not memorize this one, trust me, no way, I don't have time for that. I'm using a scientific calculator here. So I get that value. Oftentimes you could round it off, or you could just multiply out everything in a calculator by 45, which I will do here. No, for us to get the same thing, let me do it right with you. So I will use 0.9397, so that whatever you're doing, if you're working it out, me and you would get the same thing. So 9397.9397 multiplied by 45, according to my calculator, I am getting 42 points, and I'll just write out all the values, 2865, and that will be meters squared. This value here is a rounded value. That value there was rounded to 4 decimal places. So naturally the answer would also reflect the 4 decimal places. So yeah, that's basically how we use half AB sine C. I hope this video was clear enough and I trust that you understand. Don't worry about the things that you do not know, like the trig ratio, sine, and well, hopefully that's the only thing that might be hot in your head. If you are a perfectionist, like some people I know, you want to justify everything, and that's good. That's very good. That's a very good attitude to have in maths. But I think you'll understand sine a lot better when we do trigonometry, because that's really where it is first introduced. I probably jumped the gun by teaching you this formula first before you even were introduced to trigonometry. But that's the other beauty of maths. Who says it has to be linear? Ha ha ha. So that will bring us to the end of today's video. So again, as always, like, share, subscribe if you haven't as yet. Turn on that notification bell, which is the button right by the subscribe, so that this channel could grow. And of course, leave a comment if there's anything it's not clear, if anything that you want to see, if there's anything I could do for you, mathematically wise, feel free to do so. Until the next one tomorrow, God's willing, where we're going to go into our quadrilaterals, you take care.